Hi guys, my name is Adam and in this presentation, I will explain most of the things that are related to database normalization with simple examples that are easy to remember. Now, the problem is that data in the database is stored in enormous quantity and retrieving certain data is such a tedious task if the data is not organized correctly. With the help of normalization, we can organize this data and also reduce the redundant data. So we are going to start off with understanding normalization. So what is exactly is normalization? Database normalization is the process of structuring a database, usually related relational database, in accordance with a series of so-called normal forms in order to reduce data redundancy and improve data integrity. Database normalization is the process of reducing the redundancy of data in the table and also improving the data integrity. It usually divides a large table into smaller ones, so it is more efficient. Or for short, normalization is a way of organizing the data in the database. Normalization entails organizing the columns and tables of a database to ensure that their dependencies are properly enforced by database integrity constraints. Normalization is a database design technique that reduces data redundancy and eliminates undesirable characteristics like insertion, update, and deletion anomalies. Normalization rules divides larger tables into smaller tables and links them using relationships. The purpose of normalization in SQL is to eliminate redundant and repetitive data and ensure data is stored logically. The inventor of the relational model, Edgar Code, proposed the theory of normalization of data with the introduction of the first normal form, and he continued to extend the theory with second normal form and third normal form. Later, he joined Raymond F. Boyce to develop the theory of voice code normal form. Now, we're going to talk about why normalization is important. Database normalization is important to reduce and minimize data redundancy. It is important to ensure that only related data is stored in each table. The reason you normalize a database is to minimize the amount of storage space. You need to save the data, as well as make the database easier to maintain. Normalization reduces duplication of data because discrete points of data are stored only once, and then a reference to that data is stored in the other tables that needs it. Normalization also makes managing your master data easier. Next is we are going to talk about data redundancy. What is data redundancy and how do we reduce it and why? Data redundancy is nothing but a repetition of similar data at multiple places. We want to reduce data redundancy not just because of its repetition of similar data, but because it also leads to other multiple issues like insertion, deletion, and update anomalies. Data redundancy occurs when the same piece of data exists in multiple places, whereas data inconsistency is when the same data exists in different formats in multiple tables. Unfortunately, data redundancy can cause data inconsistency, which can provide a company with unreliable or meaningless information. So here we have a simple student table to store student information in a college. We have student ID, name, branch, salutation, and telephone number. Now, in this case, the branch, salutation, and telephone number are same for all the entries that we make. Whenever a new student entry is created, this entire information is repeated, and this is called redundancy. We must know that data redundancy leads to problems. There are three main problems that data redundancy causes. These are the insertion anomaly, the deletion anomaly, and the updation anomaly. Now, we are going to talk about insertion anomaly. As you can see the table, we already have 4 students in our database. If we have to add a fifth student, we will have to repeat the same data, which holds the branch data or information like branch, salutation, and telephone number again. And if we have to enter the same data for 100 more students, we need to repeat the data 100 more times, which leads to insertion anomaly because the repetition of data will only increase as we insert more entries to our table. Now this repetition arises because in our example, we are unknowingly, unintentionally saving two pieces of information in every row, student information and branch information. Now, if we start deleting student information, the branch information is also deleted simultaneously. And when we delete the last student row from the student table, we also unintentionally delete the branch information. So now we don't have any student information, and we also don't have the branch information because we deleted it, which leads to deletion problems and is also known as deletion anomaly. And now we move on to updation anomaly. So let's say if the salutation is updated with new salutations, and during the modification, even if a single row is missed out, it will lead to inconsistent data. Hence, data redundancy can also lead to data inconsistency. This results in updation anomaly. Now that we are done talking about data redundancies anomalies, we are now talking about normal forms. Normal forms helps to minimize the redundancy in relations. Normal forms are also used to eliminate the redundancy in database tables. Essentially, normalization has three main steps, and they're called normal forms. First normal form, second normal form, and of course, third normal form, and also Boy's code normal form. We will have to talk about that later. There are more normal forms than these, but once you get to third normal form, you can say that your database is pretty well normalized. Normalized is kind of a finished line. I will explain normalization in a literally physical way. It is like pouring dirty water into filters. The dirty water is your database, and the filters are the normal forms. And you have three filters: the first normal form, second normal form, and third normal form. Imagine pouring the dirty water through the top filter, the first normal form. Have very big holes, and they separate the big rocks from the dirty water and gets rid of other visible dirt. Then pouring the dirty water through the second filter, which is the second normal form. Imagine the second filter has smaller holes, which separates smaller dirt that came through from the first layer, which is the first normal form. And finally, the dirty water passes through the third layer, which is the third normal form. That if you imagine it, it has really small holes that separates unseen bacteria or really small micro-sized dirt. But this is all an illustration, and it doesn't apply directly to databases. But essentially, after you get through all those water filters, you're going to have nearly pure water, and thus it is normalized. Each normal form must have the previous one done in order to do it. So second normal form requires that first normal form is already complete. Like if you have the filters and the dirty water hits the second layer, which is the second normal form, after it hits the first layer, which is the first normal form. So before it gets through the second normal form, it must go through the first normal form. And then the third normal form, which requires the same thing. You have to go through the second layer of the filter, which is the second normal form, before reaching the third filter, which is the third normal form. So let's talk about the normal forms, starting with the first one, the first normal form. These are the conditions for the first normal form in technical terms. Number 1. A table must not contain composite or multivalued attributes. Number 2. A table must not contain any repeating groups of attributes. Number 3. Each field of table must only contain one item. Number 4. All of the data items in a column must mean the same thing. Number 5. Each row of the table must be unique. And the last one, a table must have no repeating columns. Now let's move on to the next normal form, which is the second normal form. These are the conditions for the second normal form. The data must be in first normal form. Number 2, a relation must not contain any partial dependencies. Number 3, each non-key field must be about the same thing as the primary key. And number 4, each table must contain data about only one type of thing. And finally, the third normal form. These are the conditions for the third normal form. Number 1, the data must be in second normal form. Number 2, a relation has no transitive functional dependencies. Here we have a simple table about a gaming store. Assume a gaming store maintains a database of games bought out without any normalization in database. All information is stored in one table as shown below. Let's understand normalization in database with tables example. Here you see games bought column has multiple values. Now let's move into first normal form. But before we normalize the table into first normal form, we will talk about a key first. What is a key? A key is a value used to identify a record in a table uniquely. A key could be a single column or combination of multiple columns. Primary key. A primary key is a column or a set of columns in a table whose values uniquely identify a row in a table. A primary key cannot be null. A primary key value must be unique. The primary key values should rarely be changed. The primary key must be given a value when a new record is inserted. Composite key. A composite key is a primary key composed of multiple columns used to identify a record uniquely. In the database, we have two people with the same name, Scott Free, but they live in separate addresses as shown below. Foreign key. A foreign key is a column or a set of columns in a table whose values correspond to the values of the primary key in another table. In order to add a row with a given foreign key value, there must exist a row in the related table with the same primary key value. The membership ID is the foreign key. It ensures rows in one table have corresponding rows in another. Why do we need foreign key? Or why foreign key is important? Suppose someone inserts a record in table 2 where member ID is 203, but membership ID 203 is not present in table 1. Therefore, the database will show an error. You will only be able to insert values into your foreign key that exists in the unique key in the parent table. This helps in referential integrity. The problem above can be overcome by declaring membership ID from table 2 as foreign key of membership ID from table 1. Now, if somebody Now let's move on to second normal form. It is clear that we can't proceed to make our simple database in second normalization form unless we separate the table above. So we divided our table into two, separating them into table 1 and table 2. While table 2 contains information on movies rented. We have also introduced a new column called membership ID, which is the primary key for table 1. Records can be uniquely identified in table 1 using membership ID. To move our second normal form table into third normal form, we again need to divide our table. And so we have again divided our tables and created a new table which stores salutations. There are no transitive functional dependencies, and hence our table is in third normal form. In table 3 or the third table, the salutation ID is the primary key. In the first table, the salutation ID is foreign to primary key in table 3. Now our little example is at a level that cannot further be decomposed to attain higher normal forms of normalization. In fact, it is already in higher normalization forms. Separate efforts for moving into next levels of normalizing data are normally needed in complex databases. Now let's talk about voice code normal form, which is also known as 3.5 normal form. The conditions of this normal form or voice code normal form is that it has to be in third normal form, and every functional dependencies A, B, then A has to be the superkey of that particular table, whatever that means. Let's take a look at an example of a table to completely understand Boyce code normal form. In the given table, one student can enroll for multiple subjects. There can be multiple subject teachers teaching one subject, and for each subject, a professor is assigned to the student. In this table, all the normal forms are satisfied except Boyce code normal form. Why? As you can see, that student ID and subject form the primary key, which means that the subject column is prime attribute. But there is one more dependency. That is the professor, depending on subject column. And well, subject is a prime attribute. Professor is a non-prime attribute which is not allowed by Boyce code normal form. Now, in order to satisfy the Boyce code normal form, we will need to divide the table into two parts, which is shown below. The table at the top will hold student ID, which already exists. And we will create a new column, that is Professor ID. And in the second table, which is below, we'll have the columns Professor ID, Professor, and Subject columns. Why do we need to have a new column that is Professor ID? By doing this, we are removing the non-prime attributes, functional dependency. In the second table, Professor ID will be the superkey of that table, and the remaining column will functionally be dependent on it. And by doing this, we are satisfying Boyce code normal form.